I'd like to introduce Russ Tremain, who is a Git user and build engineer here at Perforce and has a lot of sort of specialized knowledge about using Git Fusion and how we're doing that here at our offices. So without further ado, I'd like to hand things over to Russ and let him take it away.
Today I'm going to talk a little bit about how we have used Git Fusion here at Perforce to solve some interesting integration problems. I will cover some basic ways in which you can use Git Fusion to integrate content from different sources into your company's content. But first, a little background. Git was developed by Linus Torvalds to support Linux kernel development and is geared to adding a constant flow of patches from numerous contributors to the hundreds of Linux kernel modules that are now available. Often these patches are transmitted via email lists, and Git has facilities for easily generating and applying patches from email messages. Paramount among the features that Linus wanted is the ability to see the entire history of a source file that is compiled into the Linux kernel. Why should a developer have to hook up to a central repository in order to see a diff? The answer is the developer should not have to. At that time, many other software developers had arrived at the same conclusion, and there was a period when Mercurial, Bazaar, and other SCMs blossomed to support the distributed development model. Git has become enormously popular for development in recent years. There are now millions of Git repositories out in the wild. The key word here is millions. There's a reason for that. Many of these repositories are merely clones of others and do not contain unique content. An organization adopting Git as a pure development tool thus becomes embroiled in a sort of sorcerer's apprentice problem. Clone repositories soon have become yet another problem that has to be managed. The flow of commits between all these repositories can be difficult for one developer to manage on a single laptop, let alone an IT organization that's responsible for securing intellectual property for hundreds or even thousands of employee contributors. Various solutions have evolved to address the problem of out-of-control cloning. Many organizations adopt a central repository model. Git developers essentially are required to work in a centralized flow that is more widely understood. Former Perforce VP of Product Technology, Laura Wingard, popularized this idea in her book, Practical Perforce, ironically in the same year that Git was first released. The central repository model, or mainline model, as Wingard calls it, is very popular because it provides a simple yet well-understood method that can support any organization's software development workflows in a standard way. By now, Git has essentially won the distributed SCM wars and has become the dominant choice for most new open source products and for many new companies. Git has become a core skill for new software developers, and so supporting Git for these developers is an imperative that Perforce recognized early, and as a result, developed Git Fusion. With Git Fusion, Perforce elevates support for Git to the enterprise level, allowing seamless interoperation of Git clients with backend Perforce repositories. Developers thereby gain the ability to leverage a variety of Git open source technology and content for software development, while IT gets a cool redundancy, brokering, and replication features that Perforce offers. So what are some of these advantages to the software developer? To start with, let's talk about submitting a Git repository to Perforce. Once a developer has a Perforce account and IT has provided a Git Fusion server, that developer can now reparent Git repositories directly into a Perforce client view. This is a key concept. It's the Perforce client view that can be leveraged not only to support the incorporation of existing Git repositories, but also for remapping those repositories into new Perforce views, and thus into new Git repositories. This can all be controlled by the developer with minimal support from IT, using the developer's existing Perforce credentials. IT can go about its business. Secondly, how a software project evolves into Perforce is totally under the control of the developer. Does the code come from CVS, Subversion, Mercurial, RCS, even SCCS? This is only of concern to the developer, and there are a wide variety of tools that can be used to migrate these sources into Git. Once it is in Git form, one merely reparents the repository to point to a Perforce view, and the migration is complete. Third, after a repository is in Perforce, it can be remapped to any number of views that then become Git repositories as required by functional needs. For example, suppose you have a large bloated Git repository that has grown to 1 or 2 gigabytes. Under normal circumstances, the source code for that project may only be a small percentage of the overall size, and yet when a developer creates a local clone, all of the content is brought down. Git-based solutions for this problem have evolved, such as shallow cloning, but this complicates the developer's workflow. A better solution would be to use Git Fusion to remap the repository into functional views, such as a view designed for tech pubs, one designed for QA, another for development, and finally a build view that may encompass all the other views in order to drive a full-scale release. I personally have had to do this sort of mapping in Git, and it was a hellish project that I would not want to have to repeat. Try explaining filter branches to your mom sometime. To demonstrate how easy this is, here's an example where I reparent and submit my Kato open source project to Perforce, and then I remap it into several new views, one containing the base source code, one containing the regression tests for QA, another containing the Kato template sources, and yet another for technical publications. So what is Kato? Briefly, Kato is a template-based code generation language that can be used to transform or create any textual content. I've used it to convert wiki markup languages, generate large build systems, generate class hierarchies for Java, etc. Kato is a programmer's friend. Here's a diagram of the demo that we're going to do today. We're going to take our Kato open source project and import it into a master Git repository, which will have an import view. And then we're going to map that into Perforce using Git Fusion. Once we have it in Perforce, we're going to split up the repository, and we're going to create departmental views for build, test, pubs, and development. The first thing we have to do is to set up the Git Fusion credentials and user map on the VM, which I've already prepared. I'm using a little project management system I wrote a long time ago called VSPMS, very simple project management system. Basically, it's just an index of locations that you keep in a file in your home directory. Here's mine. And then when you go to that project, it sources a little file. And here's the file for this project. So I just set up some general aliases here. I use the project name for the client name for P4. Here's my account name, and here's the Perforce server. And here we just print out some variables. So the first thing I'm going to do is import the client. I also have a little alias for that. So let's do that. And here's our client. You can see this. In this project, we just have a mapping to the Git Fusion meta area. Now, I prepared the credentials ahead of time, so here I'm just copying it into our view. And now we need to add them. I'm going to use the reconcile command for that. There's another little Perforce alias. And now we just submit the changes. There we go. Next, we're going to add our user account. I'm going to add one for myself, and I'm also going to add one for the build team. We can check that with P4 users. There's the account. Next, we're going to import our open source repository into Perforce. I have another project to do that. Import the client again. Let me just show you that spec. It's very important to get this right. This is the repository location in Perforce, and this is the Git repository. Notice that we import from the root of the Git repository. Don't have any subdirectories here. Next, we're going to pull down our Git repository. That was very fast because this is a clone that I kept on my local disk. I've already pulled it down from the remote site. Next, we're going to change the configuration to reparent that Git repository to Git Fusion. All you have to do is change the parent, change the origin to the Git Fusion origin. Notice this little alias I have here. That comes from my SSH configuration file. It's a little trick that I talk about in my blog. You can configure SSH to use any credentials you like by just making an alias in your config file. So here's my alias, and I'm mapping that to host Git Fusion user get, which is the Git Fusion user, and using these credentials. We've already put those credentials in the Perforce server as part of our first step. Okay, let's go ahead and push it up to Git Fusion. I'm using the mirror option, which will push all the branches up. I only have one branch here, so it doesn't really matter, but if you did have a repository with multiple branches, this would push them all up. Now this repository has been around for 6 or 7 years, so it has lots and lots of revisions in it, probably close to 1,000 or so. The repository itself is not that big, it's on the order of 6 to 7 megabytes. So what Git Fusion is doing now is it's storing all of the objects from Git into the Perforce repository, and then it projects it into the Perforce backing store and checks it out. So now we can look at the repository using some Perforce tools. Okay, there's the object. Here's the users. So here's my user, here's my keys. And here's the user map. Now I created this user map so that when I imported the repository, it mapped my open source email to my Perforce user account. Next step, we're going to start creating views for different development teams. The first one we're going to create is the build team view, which will include the entire repository. Import. This is exactly the same view as the import view because the build team needs to have everything in its path in order to execute build. So build team is going to use Perforce, so we're going to pull it down using Perforce. And there we have the view. It's exactly the same as the open source project. So let's create some other views. Next we're going to create the development team view, which is only going to include the source code. Import. Let's look at the client. This is a bit more complicated because I'm mapping all the directories from the open source project that contains source that the development team wants to work on. So we have the main sources, the assembled sources, the regression tests, and actually this is where all the actual source is, as it's generated by Kato itself. And these are little support libraries that are required by Kato. Okay, now we're ready to check out the Git repository. So now it's pulling down the repository from Perforce. And there it is. We'll take a look at that later with our visual tool. Moving right along, let's create the QA project. Import the client. Let's take a look at the client again. The QA view has the assembled Kato interpreter and the regression tests. We want them to pull the interpreter whenever it's modified by development, so they're testing the latest sources. They're going to use Git as well, so we'll pull down a Git repository for them. This is actually creating a Git repository view in Perforce. Once that view is created, it's immutable even if you change the client. If you have to delete it for any reason, you have to go use the admin account on the Git Fusion server, and there's a nice little utility there for deleting any repository that Git Fusion has imported. So if you mess up the view, that's what you have to do. I know, I messed it up once. Okay, now we're going to create the technical publications view. There's their client. They get the books and example presentations, and this is the main documentation for the interpreter now. Now they're going to use Perforce, so I'm going to pull it down with Perforce. So there's their view. There's another one of my little utilities. Okay, so here's the documents that have been written. Any volunteers to help with that? Always welcome. Now finally we're going to create a template view. This is for template developers. A lot of Kato is in the template, and this is actually the largest part of the project. So let's import that client. Let's take a look at it. So this has the templates that are just simple templates that are hand-coded, as well as some much more complicated templates that are generated. This contains, for example, templates to generate Maven files. And these guys are also going to use Git, so let's make a Git repository. And there's our Git repository. Now let's take a look at some of these workspaces with the visual tool. We've already looked at the Git Fusion meta directory. You can start to see all the views, and these are the objects for the actual Git repositories that are saved. So these are all the Git objects, and they're exactly the same as the Git objects that would be in your ordinary Git repository. And then here's some workspace views that I'll show you. So the build view, owned by the build user, is the same as the import view. Here's the development view. So let's take a look at that real quick. This is where the actual sources are. This is actually the script that assembles the entire interpreter. And this is written in Kado. So you can see it just assembles all the different pieces. Here's the regression tests. Let's look at the QA view. So you can see the QA view contains the main interpreter, which is here. That's the fully assembled interpreter, so it's quite large. The documentation. This is actually a duplicate of the interpreter because I used to call it CodeGen instead of Kado. And then, again, the regression tests. It's all the regression tests. These regression tests are mostly written in Kado. So I use a tool called JRegress to run those. So that concludes our demo today. Okay, that's all pretty cool, but let's think about the problem from another angle. Using Git Fusion to manage workflow from outside contractors. Engineering teams sometimes need help and hire outside contractors to add capacity. Often management resists giving those developers full access to the company's resources, and IT might not be set up to monitor and grant privileges. With Git Fusion, contractors can be given a view into the source repository adequate to support their development without requiring full access to the company network. There are multiple options for managing this without ever exposing Perforce servers outside the firewall. Here is one way you might approach it. This diagram is an approach where we have XYZ Corporation having hired Acme Consulting using Git Fusion through this SSH tunnel that's poked in the firewall. All this works like a standard technology. The project manager at Acme Consulting can use Git Fusion to clone the remote repository from XYZ Corporation. This can be just a bare Git repository, and we recommend that your contractor would require straight line merges so that your shared clone of the Git Fusion repository at XYZ Corporation will also have straight line merges. That will make it easier for integration testing. In this scenario, XYZ Corporation has decided to manage their contributions via a single Perforce user account called Acme. However, Acme may have several developers, and so someone has to keep track of those developers. One way to do that is through the user map facility in Git Fusion. It's under the Git Fusion user directory, and we created one earlier when I mapped my open source project. Unknown developers, in that case, would not be allowed to integrate. From the Perforce repository point of view, all submits will be done to the Acme user account, but the original contributor's name will be retained in the Git history. Meanwhile, the build team for XYZ can continue to use their existing build infrastructure driven by Perforce submits. No changes in their process is necessary, other than the normal work of incorporating new product features. I want to talk a little bit about how we have used Git at Perforce. As the product has evolved, we have used it in several different ways. First of all, the Git Fusion development team uses Git. They drink their own ale. In build, we have used it to support versioning of Jenkins configurations. Jenkins is a build automation framework, but it doesn't know that its configurations are being stored in Perforce because it's using Git as its source control interface. I have used Git Fusion in a couple of different ways. The first was to migrate a software project that I was working on for dumping out electric commander sources. I actually initially was working in CVS because some of the other pieces I needed were also in CVS. I then migrated my CVS repositories to Git, and from there into Perforce. So I kept all my original revision history, and it's there for me to view using all the Perforce visual tools. On the same project, I used Git as an interface to Perforce. I had a choice of either using a shell or one of the other APIs, and I decided, why not just use Git? So I developed Git as a synchronization method for that project. That turned out to be really convenient because I essentially could use throwaway Git repositories when I made mistakes. Once the synchronization piece was done, I just flipped a switch and sent all those changes into Perforce via Git Fusion. I was also able to do all that development remotely on my laptop without having to be connected to a central server. There are some more details of how I did this in part 2 of my blog series on the Perforce blog site. Once the EC configurations are safe and sound in Perforce, we can use any of the Perforce visual tools to figure out what happened when. The EC project is now released open source so you can see it, and some of our customers can benefit from it. When I released it, I used Git to reparent the local repository and just point to my open source site, and I just pushed it out. I can also incorporate any fixes entered in the open source project via the Git Fusion Perforce pathway. Git Fusion offers new options for working. As we showed in the demo, some teams can adopt Git for their development, while other teams can use the visual drag and drop interfaces to Perforce. We have also shown you how to solve the remapping problem for Git using Perforce for free. Did I mention free before? Give it a shot. Here's some resources that you can check. It has my blog, the Git Fusion manual, and where to download Git to try it out for yourself. You can download the OVA just like I did and get on to your Git Fusioning. Now we'll open up the floor for questions.
Hey, thanks, Russ. So I just want to remind everyone, you enter questions just using that chat window on the right-hand side in the toolbar. And we're lucky enough to have both Russ sticking around for Q&A as well as Zig Zichterman, who's the lead developer on the Git Fusion project, and Matt Attaway, who is our community manager. So at this point, I'm going to turn it over to Matt to moderate Q&A.
Awesome. Thanks, Natalie. So it looks like we have a few questions from the community here. So one of the first ones that came in is, we talked about submodule hell and how the remapping lets you get around it. But what if I really like submodules? Can I use them with Git Fusion?
We just added submodule support in the most recent release, 13.2. It doesn't gateway your submodules don't gateway into Perforce. We back up your submodule information so that if you have a repo that has submodules, you can push and pull it and it'll be fine. But each individual submodule, which has its own separate Git, its own separate Git history, those have to be tracked separately. So we don't have a one-shot ability to push an entire repo with all of its submodules all at once.
Great. So another question coming in here is, are you planning to do a mercurial fusion someday?
I'm not, but who knows? There's already mercurial Git gateways, and we've had some success getting mercurial through Git Fusion already, haven't we? Someone's done that.
Yeah, I've played with that a little bit, because the mercurial and Git are closer as far as siblings go than Perforce and mercurial, because mercurial also has, was it Perfarce or something, to try to fake being a Perforce client.
Mm-hmm.
But the mercurial Git bridge worked pretty well with Git Fusion from when I was playing with it. But if that, I will file that request for you and make sure our product management team sees it.
Mm-hmm.
So another question about remapping: can different views overlap each other between Git repositories, and how does that work? What is that synchronizing it?
Yeah, that's a big deal. With the kind of the whole point with Git Fusion is that you can expose any subset of your Perforce depot tree as a Git repo, and since you're using a client view to map between the two, if you want to, you can move stuff around, overlap, however you want to do it. That definitely works. When you've got multiple repos all overlapping the same area, when you push from one repo, the next time someone pulls from that other repo, they get your changes. Since it's a different repo with probably a different file structure, your commit SHA-1s will differ, but the commit messages come through, the history comes through. It's just the trees that are going to be slightly different. If they have a complete and exact overlap, then there's a good chance that your trees will be identical or even be SHA-1 for SHA-1 compatible. But that's not always guaranteed. Not unless you can share the same repo across multiple Git Fusion servers if you want SHA-1 for SHA-1 compatibility.
Another one coming in here. So the connection to avoiding bloat wasn't really emphasized in the talk. So we showed in the demo how we could slice up a repository, but what else can Git Fusion do to help reduce Git repo bloat?
Yeah, the repo bloat, that's a recurring question from both existing and new customers is we've got this giant Git repo, how can we slice it up so it's not giant anymore? The dominant fix is if you've got a big folder of stuff you don't need, don't map that into your repo. Take your existing giant repo, push it into Perforce, and then define a new view that slices out the parts that you don't need anymore that are giant. So if you've got a repo that has like your entire game project, including all your giant art assets, make another repo just for developers that doesn't include the giant art assets. There are other tools you can use. Most Git users know about shallow clones. You can just grab the head commits. You can do something similar with Git Fusion. However, with Git Fusion, it's a fully functional repo. You can still push and pull to it. You can say, just grab history starting at some date. So if you've got a lot of ancient history you don't need and you want to keep your repo small, slice off the old stuff by time, and you can clone and you can just sort of pick up work for recent. That also works for, since all that history is still in Perforce, you're not actually losing any of that history. So you can still have the giant repo with all the history for when you really need it, but then the working repo that you're working with can just be, the current development effort, the current project cycle. Done.
Excellent. So another question coming in is, what Git tools will Git Fusion work with? Is there any sort of restrictions in place or limitations there?
Yeah, we work with a very limited set of Git clients. We only work with all of them. I have yet to see a Git client that doesn't work with Git Fusion. It's just straight Git. On the Git Fusion side, you're just connecting to a normal Git remote. We actually use Git itself on the inside of Git Fusion, so it's normal Git back and forth. I've used Git Tower, Git Box, the Git Command Client, Git K. They all work.
Awesome. What else do I have here? One last one. The demo went by pretty quickly. How exactly were users choosing what files went into a Git repository?
Users, the admin who's defining the Git repo decides which views or which files go in the repo by defining that client map. I know it went by pretty fast, but if you noticed, a lot of the demo was about defining mappings, defining these views. Those views with those lines that map portions of the Perforce depot tree into what will become the Git repo, that's how you select it. So there was one client definition that you saw was a single line, and it just mapped like an entire folder into ... That was the giant view, which had everything. And then you saw other views which just pulled in a subset, maybe this folder here, the source here, these test files here, or these support libraries here. Those were more specific and smaller client views that just grabbed those files, and those became smaller repos.
Great. Thanks, Big. Well, that's all the time we have for questions today, but if you have any follow-up questions, you can always find me on Twitter, P4Mataway, or out on the forums, so we're always available if you have more questions after this. We'll also be sending out a recording of this talk as well as the slides from this. So thank you, everyone, for joining us today, and thank you, Russ, for all this. Thank you very much, guys. Take care.